Have you ever had that strange feeling, that sense of déjà vu, or wondered if the world around you is truly real? What if I told you that everything you see, everything you feel, your friends, your family, this very moment, is nothing more than an incredibly advanced computer simulation? It sounds like the plot of a blockbuster movie, but this is a question that some of the most brilliant minds on our planet are seriously considering. Could our entire universe be a program running on a cosmic supercomputer? This isn't just a random thought experiment. The idea has roots in ancient philosophy, from Plato's allegory of the cave to Descartes' evil demon. But it was philosopher Nick Bostrom who brought it into the 21st century with his groundbreaking 2003 paper. He presented a chillingly logical argument that has since captivated physicists, tech visionaries, and philosophers alike. It's called the simulation hypothesis, and tonight we're going deep down this rabbit hole to explore the evidence, the paradoxes, and the profound implications of what it would mean if our reality is not what it seems. So, buckle up. We're about to question the very fabric of existence. Is our life a sophisticated game, and are we just players in it? Let's find out together. Before we dive into the mind-bending specifics, let's break down Bostrom's core argument. It's surprisingly simple, but its conclusion is what makes it so powerful. He presents what's known as a trilemma, meaning that one of three propositions is almost certainly true. First, the chances are that any civilization advanced enough to create incredibly detailed conscious simulations will simply go extinct before they ever get there, maybe through war, climate change, or some cosmic catastrophe. So, no simulators, no simulations. Second, an advanced civilization could develop this technology, but for some ethical or moral reason, they choose not to. Perhaps they'd see it as a form of digital slavery, or maybe they just lose interest and would rather explore the physical universe. In this case, again, no simulations are created. And now, for the third and most unsettling possibility. If the first two propositions are false, then it means that advanced civilizations do reach a point where they can create simulations, and they do create them. And they wouldn't just create one. They would likely create billions or even trillions of them. Think of how we create video games today, from simple pixelated worlds to vast open-world RPGs. Now, imagine that technology advancing for thousands or even millions of years. They could simulate entire universes, complete with conscious beings who believe their world is real. Here's the statistical punchline. If countless ancestor simulations are being run, then the number of simulated consciousnesses, like us, would vastly, overwhelmingly, outnumber the real, organic ones in the base reality. By sheer probability, it becomes almost a statistical certainty that we are not the original civilization. We are one of the countless simulated ones. When you roll the dice of existence, the odds are just stacked against you being in that one single base reality. So that's the argument. Either civilizations like ours almost always die out, or they lose interest in creating simulations, or we are almost certainly living in one. Suddenly, the question isn't, are we in a simulation? But, which of these three scenarios is the most likely? And that's a much harder question to answer. You might be thinking, okay, that's a neat philosophical puzzle, but where's the science? Is there any actual physical evidence that could point to our universe being a simulation? And this is where things get really fascinating, because some aspects of our universe look suspiciously digital. Let's start with the very small. When you zoom in on a digital image, you don't get a smooth, continuous picture. You eventually hit the fundamental unit, the pixel. The image is quantized, meaning it's made of discrete, indivisible units. Well, our universe seems to work the same way. At the quantum level, things like energy, space, and time aren't smooth and continuous either. They come in tiny, indivisible packets called quanta. Max Planck, one of the fathers of quantum mechanics, discovered that there's a smallest possible length in the universe, known as the Planck length. You can't have anything smaller than that. It's almost like the universe has a resolution, a fundamental pixel size. Then there's the weirdness of quantum mechanics itself. Particles that don't have a definite state until they're observed, almost as if the universe is only rendering the details when a conscious observer looks. This is known as the observer effect. It's like a video game that only renders the part of the map you're currently in to save processing power. Why would the universe bother defining the spin of an electron if no one is there to measure it? This has puzzled physicists for a century, but in the context of a simulation, it makes a strange kind of sense. It's a resource optimization strategy. Even the laws of physics themselves could be seen as the algorithms of the simulation. Constants like the speed of light could simply be the processing speed limit of the cosmic computer running our reality. In 2012, a team of physicists proposed a test. They argued that if our universe is a simulation running on a grid, there should be tiny anomalies in the behavior of high-energy cosmic rays, subtle distortions that would reveal the underlying structure of the space-time lattice. So far, we haven't found this glitch in the matrix, but the fact that scientists are devising actual, testable experiments shows just how seriously this idea is being taken. It's moved from the realm of philosophy into the world of theoretical physics. Of course, for every argument in favor of the simulation hypothesis, there's a counter-argument. Many physicists believe that these digital-like features of our universe are just natural properties of reality, and trying to explain them as a simulation is an unnecessary leap. They argue it's an unfalsifiable hypothesis, meaning we can't definitively prove it wrong. After all, any evidence we find against the theory could just be part of the simulation's code, designed to trick us. And this brings us to the deep philosophical paradoxes that wrap the entire idea in a beautiful, unsolvable knot. If we are living in a simulation, what about our simulators? Who are they? Are they organic beings in a base reality? Or is it possible that they themselves are just another simulation, created by an even more advanced civilization? This creates a potentially infinite regress, a matryoshka doll of realities, each one nested inside another, with no way of knowing if you're at the top or somewhere in the middle. The beings in each layer would likely believe their reality is the true fundamental one. The simulators might be running our universe as a scientific experiment to study the past, or maybe it's just a form of entertainment for them, the ultimate video game. We would have no way of knowing their motives. This also raises profound questions about consciousness and free will. Are our thoughts truly our own? Or are they just lines of code executing in a program? If every decision you've ever made was predetermined by an algorithm, does that mean you have no real agency? This is a terrifying thought for many, but some philosophers offer a more optimistic view. They argue that even if our consciousness is simulated, it doesn't make it any less real. Your thoughts, your love for your family, your joy, your suffering, all of these experiences are real to you. A simulated pain still hurts. A simulated joy still feels wonderful. From our perspective, inside the system, the experience of consciousness is authentic, regardless of the underlying substrate it's running on. So, what does all of this mean for our daily lives? If there's a chance we're living in a simulation, should we just give up? If nothing is real, does anything truly matter? I think that's the wrong way to look at it. In fact, embracing this idea can be incredibly liberating and even inspiring. Think about it. Whether our universe is a physical base reality or a simulated one, the rules are the rules. Gravity still works. Kindness is still a virtue. The sun will still rise tomorrow. The simulation hypothesis doesn't change the game we're playing. It just changes our understanding of the game board. In a way, it makes life even more magical. It encourages us to be more curious, to look for the glitches, the strange synchronicities, and the beautiful patterns in the world around us. It's a reminder that reality is far stranger and more mysterious than we can possibly imagine. It pushes us to live more boldly. If this is a game, why not play it to the fullest? Why not strive to be the best version of yourself, to explore, to create, to love? Perhaps the most important takeaway is a sense of humility. The theory reminds us that we are probably not the pinnacle of intelligence in the cosmos. It opens our minds to the possibility of realities and beings far beyond our comprehension. It forces us to confront the limits of our knowledge and to accept that some questions may never be answered. Ultimately, we may never know for sure if we are living in a simulation. The answer might be forever beyond our reach, locked outside the boundaries of our simulated universe. But in the end, does it really matter? The mystery of existence is what makes it so precious. The search for answers is what drives us forward. Whether we are code or cosmos, the experience of being alive, of being aware, of being able to ask these very questions is a miracle in itself. So the next time you look up at the night sky, don't just see stars. See a tapestry of possibilities. See the elegant code of the cosmos, and remember that the greatest reality might not be the world outside, but the conscious mind within that has the capacity to wonder about it all. Thank you so much for joining me on this journey down the rabbit hole. What do you think? Are we living in a simulation? Let me know your thoughts in the comments below. And if you enjoyed this exploration of reality, don't forget to like this video and subscribe for more deep dives into the biggest questions of science and philosophy. Until next time, stay curious.